A warm greetings to one and all. In this session, let's learn about base rule and independence and conditional independence. Let's start with base rule. So combining the definition of conditional probability with the product and sum rules yields base rule, and it is also called as Bayes theorem. The formula is probability of EI gives A is equal to probability of EI into probability of A given EI divided by summation of K is equal to 1 to N probability of EK into probability of A given EK. According to the conditional probability formula, probability of EI given A is equal to probability of EI intersection A divided by probability of A. Let's consider this equation as equation number 1. Using the multiplication rule of probability, probability of EI intersection A is equal to probability of EI into probability of A given EI. Let's consider this equation as 2. Using total probability theorem, probability of A is equal to summation of K is equal to 1 to N, probability of EK into probability of A given EK. Let's consider this equation as 3. Putting the values from equation 2 and 3 in equation 1, we get probability of EI given A is equal to probability of EI into probability of A given EI divided by summation of K is equal to 1 to N probability of EK into probability of A given EK. Bayes rule is probability of A given B is equivalent to probability of B given A into probability of A divided by probability of B, where probability of A is the prior probability, that is probability of event A. Probability of B is the probability of event B. Probability of A given B is posterior probability, where probability of event A given B happens. Probability of B by A is likelihood, that is probability of event B given A happens. Let's have an example for Bayes theorem. A man is known to speak the truth 2 out of 3 times. He throws a die and reports that number obtained is 4. Find the probability that number obtained is actually a 4. It is given that let A be the event that the man reports that number 4 is obtained. Let E1 be the event that 4 is obtained and E2 be its complementary event. Then probability of E1 is equal to probability that 4 occurs. That is the number of favorable events divided by total number of occurrences. So the favorable event which we required is having the occurrence of 4 divided by total number of occurrence in the dice is 6. So it is 1 divided by 6. Probability of E2 is equal to probability that 4 does not occur is equal to 1 minus probability of event, which is equal to 1 minus 1 by 6. It is 5 divided by 6. Also, probability of A given E1 is equal to probability that man reports 4 and it is actually 4. We know that the man speaks the truth 2 out of 3 times. So it can be written as 2 divided by 3. P of A given E2 is equivalent to probability that man reports 4 and it is not a 4. So he speaks false 1 out of 3 times. So it can be written as 1 divided by 3. By using Bayes theorem, probability of E1 into probability of A given E1 is equivalent to probability of E1 into probability of A given E1 divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So now we have to substitute these values. The value of probability of E1 is 1 divided by 6 and probability of A given E1 is 2 divided by 3 divided by probability of E1 into probability of A given E1, that is 1 divided by 6 into 2 by 3 plus probability of E2 into probability of A given E2, that is 5 by 6 into 1 by 3. So now the probability that number obtained is actually a 4 is 2 divided by 7. So hope you are clear in this problem. Let's have another example problem. Here you have two bags. One is of pink color, the other one is of yellow color. Pink bag contains 3 mangoes and 7 apples, whereas yellow bag contains 6 mangoes and 4 apples. You randomly choose a bag and then randomly pick one fruit from that bag. The fruit you pick is an apple. So, what is the posterior probability that you pick from the pink bag? Let's find the solution with prior probabilities. Since you have randomly chosen a bag and each bag has an equal probability of being chosen, probability of pink bag is equal to 1 divided by 2, which means we have total 2 bags out of which we are choosing pink bag. So it is 1 by 2, which is equal to 0.5. Similarly, the probability of yellow bag is equal to 1 by 2, which is equal to 0.5. Next, we can find the likelihoods. The likelihood is the probability of picking an apple given you chosen a particular bag. Probability of picking an apple from pink bag is probability of apple given pink bag, which is equal to 7 by 10. That is, we have 10 fruits in pink bag, out of which we have 7 apples. So it is written as 7 divided by 10, which is equal to 0.7. Then probability of picking an apple from yellow bag is probability of apple given yellow bag is equal to 4 divided by 10. That is, in yellow bag we have 10 fruits, out of which 4 belongs to apple. So we have written as 4 divided by 10 is equal to 0.4. To find the posterior probability that you picked from pink bag given that you picked an apple. Probability of pink bag given apple is equal to probability of apple given pink bag into probability of pink bag divided by probability of apple, where probability of A is the total probability of picking an apple from either bag. Probability of apple is equal to probability of apple given pink bag into probability of pink bag. So we have found the value for this already. We can see here in likelihood. Probability of apple given pink bag is equal to 7 divided by 10, which is 0.7. Then probability of pink bag, that is probability of pink bag is 0.5. So we can substitute the values as 0.7 into 0.5. Then plus probability of apple given yellow bag into probability of yellow bag. So we have found the likelihoods also for the same. The probability of picking an apple from yellow bag is 0.4. That is probability of apple given yellow bag is equal to 0.4. Similarly, the probability of yellow bag is 0.5. So now we can substitute this plus 0.4 into 0.5 is equal to 0.35 plus 0.2, which is equal to 0.55. Now we can calculate the posterior probability. So probability of pink bag given apple is equal to 0.7 into 5 divided by 0.55, which is equal to 0.35 divided by 0.55. The answer is 0.636. So the posterior probability that you picked from the pink bag given that picked an apple is approximately 0.636 or 63.6%. Hope you are clear in this problem. Let's learn about independence and conditional independence. So first, independent event. If the probability of occurrence of an event A is not affected by the occurrence of another event B, then A and B are said to be independent events. An event A is said to be independent of another event B if the probability of occurrence of one of them is not affected by the occurrence of the other. So, two events A and B are said to be independent if probability of A intersection B is equal to probability of A into probability of B. Let's have an example here. The event of tossing two coins simultaneously, the outcome of one coin does not affect the outcome of another coin. Then they are independent events. Next, conditionally independent. Here, two events A and B are conditionally independent given that event C with probability of C greater than 0 if
Probability of A intersection B given C is equivalent to probability of A given C into probability of B given C. Or equivalently, probability of A given B intersection C is equivalent to probability of A given C. Let's have an example. So by assuming that selection for IAS and IPS is based on candidates' performance in UPSC exam. Are the events selection for IAS and selection for IPS conditionally independent on UPSC exam performance? This can be expressed as probability of IAS given IPS intersection of UPSC is equivalent to probability of IAS given UPSC exam. So hope you are clear in independence and conditional independence event.
Thank you all.